Hello and welcome to my channel. Today we're going to continue with our build of the huge mechanical eye, or eyeball. The main idea is to make this motorized mechanical eye, which will follow you. So we're going to use artificial intelligence, more precisely object detection or pose estimation, we will see. And like this eye is going to follow the people around, or maybe more precisely the faces around. And in order to make everything more interesting, I'm going to make it kind of overkill, over-engineered overkill. So I use the powerful motors for small and light camera. Yeah. So I hope that this eye is going to be really fast, like choo, choo, choo. But we'll see this. Last time we finished the mechanical build, and in this video we need to finish the electronics and we need to program it. I hope that it's going to be simple and fast. Let's get started. In the previous video we have installed this camera. This is USB web camera from Microsoft. And actually I don't really like it and I decided to change it. Why I don't like it? Because it does not have a really wide angle of view. Even though it's positioned like a wide angle camera, but it's not really wide. So I have bought a new camera, CSI one. And this camera has angle of view of 200 degrees, almost like a human eye. And I think it's quite important to use a wide angle camera here. Because with this eye will be able to see the people even when this eye is looking almost in another direction. Okay, not really another direction, but like at almost 90 degrees it looks away. You come in here and it's like, I see you. Also, I have bought 1 meter CSI cable. I hope that it's going to be enough. If it's not enough, I don't know what I'm going to do, but we'll see. In order to fix the new camera, I have 3D printed this piece, in which I will put this 3D printed black piece. This black piece I need just from aesthetic point of view. Like this, I have a black center over here. And the camera itself is going to be held with this bracket. I have also started to do some electronics, and you see I made this plate with the Jetson Nano and with the power supply. If for some reason we will see that Jetson Nano is not powerful enough, we will go with another overkill and use Jetson Xavier NX. But I think Jetson Nano should be enough. It would give us at least 10 frames per second, and 10 points per second for the eye. I think it should be okay. Otherwise we will go with this one, and with this one we will have the frame rate of 80 or 70 frames per second, which would be like plenty. Yeah, but this project about overkill, so maybe we will go with this one. Let's try the pose estimation with our new camera. Oh, it seems like it works. And even when I'm at almost 90 degrees with respect of the line of view, it's still working. This is perfect, and we have 15-16 frames per second, which should be okay. So we can continue with the installation of camera. Embedded nuts installed over here. Now this piece. Now the camera goes here. Like this, all the way in. And this piece goes on top. It looks cool actually. And I still can use the original cover for the lens to protect it. I have installed a new camera. This is the cable from this camera, which is coming out. It's not actually a long cable, because I used some part of this cable inside this ball in order to allow for the motion. And now I need to put this cable around this base in order to allow for this motion. And in order to hide my mess with the cables, I'm going to use this piece, which will go over here. But in order to fix this piece, I need to replace the base, because this base has the screws, 6 of them, and there is no such screws on the original base. And these screws I need in order to fix this piece. So you'll see this in a moment. So this is installed, the wires are inside, this rotates like it should be from one end to another end. And now we need to take care of the electronics. For this I have 3D printed a huge box over here, where I already installed a huge fan, 120 millimeters. And we need to put here Jetson Nano and ODrive. For the Jetson Nano I have made this So power supply, Jetson Nano, and it's going over here. And for the ODrive, I made this one. So this is the power supply, break-in resistor, and ODrive itself. ODrive is just fixed to the cover of the power supply. I'm not really proud of this design, but at least I use washers. And this piece will go over here. There is not much space there, but it fits. And over here some switches and button. Now I need to connect all of this. And after I'm going to install this box at the back. I have mostly finished the wiring. I need to take care of this long wire. I need to make a shorter one. This wire connects ODrive to the Jetson Nano over there. The cable for the camera was barely long to connect to the Jetson Nano. Now let's try to do the calibration of both axes. First this one and second this one. It seems like both actuator works. Whew. There is still hope for this project. Cool! While I was programming the eye, I have received this box. It's kind of related. Let me show you what is inside. We should be careful. It's written fragile. Haha! NVIDIA! It's quite big box. Jetson AGX Orin developer kit. Yay! For the size comparison, I found the box from the Jetson Nano 2GB. I think this is less expensive Jetson ever existed. And this is, I think, the most performant and most powerful Jetson. Jetson AGX Orin developer kit. You see the size difference? The price difference is even higher. This box is empty, so I can do this. Now let's open it. Oh, it's quite heavy. 2 USB here, some buttons, internet, display port. Actually, this gray part, it's made out of metal, and the black part is from plastic. The rest of the unboxing you will see in my next video. I have finished the wiring. There is not much space left. This box is quite tight for this electronics, and it's quite difficult to work, but everything is inside. I have not put yet the top cover because I still have the screen connected to the Jetson Nano. The idea is to make kind of closed system without any screen, without any keyboard, just with the cable for the power. I have made one modification of camera, and what I did, I changed the cable from the camera to the Jetson Nano. So the original cable was this kind of cable, the ribbon style cable, but the longer one. And this cable made a lot of problems. At some point I thought that this project is not going to work, but now I think it's going to work. So what was the problem? The problem was inside this arm. So here I have all the cables which are coming from this ball, the cables from the motor, there was this ribbon cable here, and the cable from the encoder. I think the cable from the encoder it's not a problem, but the cable from the motor has a huge problem because this is a cable with a high current. And this is not like a DC current, it's like changing current. And that's why this changing current was inducing some noise inside this CSI camera. And this noise apparently was so huge, it forced my Jetson Nano to reboot every time when I use the motor and the camera at the same time. And at some point I even thought that it's not going to work like this at all and I need to redo everything. But finally I found the solution. And for this solution I use the adapter from this ribbon style CSI camera cable to the HDMI cable. Afterwards I used 2 meters HDMI cable, like this one for the screen, very thin one and very flexible. And the thing that this HDMI cable, first of all, it's thin cable, and the second point, this cable is shielded. So this cable is better for the harsh environment which you have inside this arm, where there is high current cable and this signal cable. I have already wrote the initial program. I reused the program PoseNet, which you saw before, which gives this nice skeleton when I move in front of the camera. Over here I have added the ODrive module, which I installed before. And afterwards, somewhere here, I do the ODrive stuff. I do the calibration, So here first I do the encoder calibration. From this ODrive automatically finds the shift between encoder position and the motor position. This is necessary for work of the ODrive and any other controller with the encoder. And after this, I do another type of calibration, which I do basically manually, and I move this ball from one hard limit, like over here, to another hard limit over here. And like this, when I know these two hard limits, I can know absolute position of this ball. So first calibration gives us kind of relative position, and the second calibration gives us absolute position. And when we do this all calibration, we go to the home position, which I defined like this, looking straight forward. And after inside the while loop, I do some magic. So first of all, over here, I find the position of the eyes. Actually, I find the position between two eyes. And this code I stole from the James Bruton. You all know him. And afterwards, I tried to do some kind of PID control, but with only P. So it's not really PID, it's P control, like the simplest one, just to start. In these two lines, I checked that we don't go beyond the hard limits, which we found during our absolute calibration. And over here, I move this eyeball. Easy. Let's see how it works. Now let's run this program. I have speeded up the video of the calibration because the calibration is quite slow, and this is made specially in order to be quite precise. Now let's take off the cover from the camera. As you can see, it kind of works. Now it doesn't see me. Cool, it works. And when I close the window, it automatically disables the motor. This kind of works, but I think we can do better. And instead of using PID control, which is not really PID, we can use trigonometry. You know, this thing with the sine, cosine, tangent, and stuff like this. So let me try to explain what I would like to do. So this is the camera. It looks over there. And it sees something there. Some kind of picture. Somewhere in this picture it detects that there is a face. So, and basically it means that it should move over here. From here, where it was, over here. And this means that we need to calculate the angles for the first axis and for the second axis, in order to move precisely from arbitrary position to the position where the camera saw face. So this camera, it moves kind of in the spherical coordinates. So there is phi coordinate and theta coordinate. And this is what I'm going to use for my trigonometry, whatever. And after some time, actually after a whole day, I found formulas, this one and this one, which in the limit of theta approximately pi over 2, where the tangents is equal to the infinity. In this case, when the theta is around pi over 2, we can use this formula, because the original formula does not work. It has the 0 divided by 0. And for the theta, in this case, it's like this. So basically, I use this formula everywhere, except theta equal pi over 2, where I use this formula and this one. So easy. Whew. I'm pretty sure there is a mistake here, but I don't know where. You see my nice fan? It's glowing. This is actually 12 volts fan, which I connected to the 5 volts. So it's rotating not very fast, but I think it would be enough. And it looks quite flashy. And so I have implemented these formulas in our program. And this analytical solution is over here, where I have one case when the theta is close to the pi over 2. I have another case elsewhere, and I still look at the two cases when the theta is more than pi over 2 and the theta less than pi over 2, because I have a square root in my formula, and this square root is positive or negative depending on where the theta. Complicated. Let's run it. Let's take off the cover from the camera. Yeah, in my opinion, it works way better. The motion is not perfectly smooth. It's okayish, but it's not perfectly smooth. I don't know if this is because of the backlash or because of my program. And it works at different angles. So it works when it's like this horizontal, and it works when it's like this almost vertical. And the last thing which I would like to try is to replace the Jetson Nano with the Jetson Xavier NX, which is way more powerful. And I would like to see if with this one we will be able to have the more fluid motion from our eyeball. The Jetson Nano gives us around 15 frames per second of the pose estimation, and Jetson Xavier NX should give us around 80. I have took off the Jetson Nano and I have connected the Jetson Xavier. It's not properly placed for the moment, but I'm going to test it like this. And if it's going to work, we're going to put it inside. I'm going to use exactly the same program with analytical formula, which I used with the Jetson Nano. I hope that I don't need to change any coefficient, but probably we do need to change them. Let's try to take off the cover. This is way more fluid. The motion is perfect. And after a couple of minutes, my program stopped with an error. Failed to retrieve next image buffer. I found the solution on the internet. It's not that I'm really smart, it's just someone smart on internet. Yeah, so this is a solution which I tried and it looks like it works. Let me show you. Now let's uncover the camera. You see, the camera is quite fast. I'm tired. I'm too fat. I'm too old to do this. But it's cool. Yeah, it works. Look there, at camera. Look at camera. At camera over there. Like this. Yeah, it works. The Jetson Xavier module is installed. The configuration of the fan is not optimal for the Jetson Xavier because Jetson Xavier blows in this direction and the fan blows in the opposite direction. But because this fan rotates really slowly, it should not be a problem. I also connected this button over here which is going to switch on and off the Jetson. So like this, it would be possible to use this device without screen. So it's going to be like standalone device. As you can see, I closed the electronic box, so there is no any screen or keyboard connected. To power it on, first this switch, and after this button in order to power the Jetson. And on the other side there is an LED fan, which looks quite cool. As you probably figured out, the main program starts at the startup. And in order to do this, I made this file run.ch and I put this file in the startup application. And also I have added our main program. So I have disabled the output because I don't have the screen, so I don't need to see the feed from the camera. And I also added these lines in order to disable the motor at the power off of the Jetson. So when I power off the Jetson, the motor is disabled like this, they are not heating up for nothing. Let's uncover our camera. Ah yeah, it works. Today we have learned at least 3 things. First of all, don't put CSI ribbon camera cable next to the cables with the high current from your motor. Because of the Maxwell equations. The change in high current in the motor cables induces the change in magnetic field. And change in magnetic field induces the voltages in the ribbon cable. And these parasitic voltages, basically noise, is quite high in the case of the ribbon cable because it has a high surface. And because of this, Jetson Nano can reboot, it does not work properly, it's nightmare. So instead of CSI ribbon cables, use HDMI cables. Because they are thin and they are shielded. Like this, they are better protected from the interference. Second thing which we learned. Jetson Nano is good, perfect, but not for the fast robot. If you want to build simple and not very fast robot, Jetson Nano is perfect. But if you want to build simple but fast robot, Jetson Nano is limiting. You would have to use Jetson Xavier NX, like I've used here. And if you want to build sophisticated and fast robot, I'm pretty sure you would need to go to something like AGX Orin, which is quite expensive, but way more powerful. And the third thing which we have learned is how to run your Python program at the startup. I think it's not complicated and most of you knows, but still. And how to deal the shutdown in the Python program. And like this we can build the standalone robot with the Jetson, which does not require screen or keyboard. And as you can see, it works perfectly fine. I should say that from the psychological point of view, it's kind of creepy, because this eye always follows you. And even though I know that this is mechanical, it's not alive, and I should look at the camera, but I want to look at this eye because I want to understand why it follows me. And I want to understand if it's dangerous for me, if I should run, or if I should scare it. Yeah. As usual, huge thank you to people who support me via Patreon and via YouTube channel membership. Here are their names. And in return, I share the CAD files and all the files necessary for this build and for every build in my video with some of my patrons. So if you would like to build the same eye, or if you would like to use my program or something else, become my patron, download the files, use them. Please don't forget to put the like to this video, like this it's going to promote this video, my channel and the projects like this one. As usual, stay safe, good luck with your projects and see you next time.